Lights, Camera, Action Potential by Mary Herc, Alexandra Pissarro, and Michael Romer. The dendrites are branch-like structures that project from the cell body. They are the first part of the neuron to receive the signal from the neurotransmitters released from other neurons. The cell body contains the nucleus, and the long projection coming off of it is the axon. The axon is the longest part of a neuron that propagates a signal to the axon terminals. The axon is surrounded by a myelin sheath that allows the signal to be transmitted. The axon terminal is the final destination for a signal before it is transmitted to the next neuron. This is the legend that contains everything needed for an action potential in the movie: acetylcholine, acetylcholine esterase, acetylcholine-gated sodium channels, calcium ions, potassium ions, sodium ions, voltage-gated calcium channels, voltage-gated potassium channels, and voltage-gated sodium channels. There are a large number of voltage-gated ion channels that are found in the cell membranes of the neurons. These channels allow for the movement of sodium ions, potassium ions, and calcium ions into and out of the cell during an action potential. The beginning charge inside the cell is negative 70 millivolts. When a stimulus depolarizes the membrane to reach the minimum threshold of activation, voltage-gated sodium channels are the first ion channels to open. As sodium channels open, some sodium ions rapidly enter into the cell. Once a significant amount of sodium rushes into the cell, the voltage-gated sodium channels close and no more ions come in. This changes the charge on the inside of the cell to become less negative. Voltage-gated potassium channels open in response to this depolarization caused by the initial influx of sodium into the cell. The movement of potassium ions out from the cell repolarizes the membrane back to its negative resting potential. In the neuron, voltage-gated calcium channels are only found in presynaptic axon terminals. Activation of these voltage-gated calcium channels allow for the movement of calcium into the cell. The calcium entry triggers a release of a stored neurotransmitter called acetylcholine from vesicles in the presynaptic cell. A synapse consists of a presynaptic terminal of one cell and the adjacent postsynaptic membrane of the next cell. The small gap between these terminals is called the synaptic cleft. Acetylcholine is then released from a presynaptic terminal. Once released, it binds to and activates the acetylcholine-gated sodium channels in the dendrite of the postsynaptic neuron. The activation of these channels allows for sodium entry into the postsynaptic membrane. Acetylcholine is then rapidly degraded and inactivated by acetylcholine esterase enzymes in the synapse. The process is then repeated with another neuron until the signal propagation is terminated.